Now we're going to talk about arcs and what we call central angles and how to name these arcs and the different kind of arcs. You learned about what an arc was, and now you're going to learn how to name it and so forth. So here's the vocabulary. You have this on your paper. We have a central angle.
Okay.
A central angle is an angle whose vertex is the center of the circle. On your sheet that you have a central angle. We'll find it in a minute. I'll let you write that down. I have drawn a central angle.
FJD.
On yours, it is FJD is the angle. Notice it's not a sector. It's the edges of, it's the angle portion of the sector. That only works if the vertex is the center of the circle.
So GJF would work too.
GJF will also work. Our next one is called a minor arc. A minor arc is an arc formed by a central angle that is less than 180 degrees.
So FD?
Arc, FD. Yeah, so you'll want to write the little arc above it. So if you're going to put an FD, you need to put an arc so we don't think it's a segment.
Shoot, we need to write this little sign thingy. Okay, what was central angles thing?
FJD, angle FJD.
Yeah. You don't have to name it, but if you wanted, yes.
I want it just in case. Okay,
Okay. So that is a minor arc. A major arc is an arc formed by a central angle. What do you think that one's going to be?
Greater than 180?
Yes.
Oh, greater than 180. Not greater than 90, but greater than 180.
Yes.
So it can't be exactly 180? Because we don't have one.
We'll talk about what exactly 180 in a moment. Good.
Oh,
You have a major arc that is associated with FD. It's the other way around. You can start with F, go your way backwards. But G, go towards the G and get back to the D. That is a major arc. Go backwards around. This was the minor arc. This is the major arc. Okay. I want you to notice that how many letters did I use for a major arc?
3.
3.
To tell you which way to go.
Yeah, because I could have, if I named it FD and FD, you would know which one's the major and the minor. So when it's a major, you're going to make sure you put that third one in there so you know which direction to go through.
Oh, wait, okay, so I'm catching. So F. I would just go around like the whole outside of F.
Yes, so you're going to start here at F. Start with F and go towards G. I could have also named it FXD if I wanted to, because you're going that direction. Does that make sense? I could have named it starting with D. I could have started it with D and moved around to X and background also. Okay, so I could have named it a different way. So that F and that G there could have been an X.
So FGD.
Yes.
Okay, so it could also be like the DXC thing.
Yeah, you
or F?
only need 3. So if I would have done DXF or DCF or DAF. Okay.
So technically we could have done this in like reverse.
Yes.
DGF.
Yes.
Yeah.
Yes. Yes. Semicircle. This is semicircle. A semicircle is an arc whose endpoints are on the diameter. It's also like the equal 180 degrees, but it's an arc whose endpoints are on the diameter. You have one of those also, and you might want to kind of go underneath your...
So just go underneath?
I would, or on, yeah, with your color. Yeah, so it starts at G and goes around to D.
Okay. So
Or up above, too, by the way. But
where?
I think it goes better underneath.
Yeah.
So just like...
It's wait. I don't actually. It's just this part.
Yes,
it's
that's
all
that's correct.
So like
That's
the
just the semi. That's part of the circle is the semi. That's part.
So like this GXD thing?
Yes,
Like just-
yes. And I'd kind of go maybe inside or outside, not on top, but it's up to you.
So it's an arc GXD?
Yeah. All right. Here's the circle.
Golly.
I have just drawn what?
A central angle?
Very good. A central angle because it's P is at the center. Here's our central angle. And I named it A, P, B. Can you give me a minor arc?
A, B, B.
A, B, and I'm going to put a little arc with it. All right, so this is kind of a review, right? Can you give me a major arc? It's A, C, B. That's correct. Now here's, what did I just put there?
The diameter.
A diameter. And I have a semicircle, which is D, C, E. I could have named it others. I could have gone the other direction. And there's a little note, which we already have talked about. The notice that the major arcs and semicircles are named with 3 letters, and minor arcs are named with 2. Okay? Questions?
What about congruent?
Now we're going to talk about that. How do we measure an arc? This is number 9 on your theorem sheet for anybody who wants to know. How do we measure an arc?
Oh, that's the one that doesn't have a picture to it.
This is the one that doesn't have a... Is this the one that doesn't have the picture to it? Okay. I can give you a picture if you'd like one. An arc has the same measure as its central angle. So, if this angle is an 80-degree angle, arc AB is an 80-degree arc. Okay? How much... Let me see. I'm not sure if I'm going to... Okay, so that means if ACB equals 80, so arc AB is 80 degrees. How in the world did I get this one back here? Why did I subtract from 360?
Because 360 is a circle.
360 is a full circle, so if I wanted you to tell me the major arc's measure, I would subtract it from 360 to get the 80 degrees. Are you with me so far? Okay, good. All right. An ADE is half the circle, and it's 180. Are you with me so far?
Mm-hmm.
Okay, because it's the semicircle, correct? And notice that I named it with 3 letters. All right, now we're going to, this is a theorem number 4. This is very similar to 2 we've already had before. We added segments, and we have added angles. Now we're going to add arcs. So if I have this AB right here, and I added it to BC, it would equal the whole, no, not the color, it would equal the whole thing. The 2 pieces add up to the whole. We had angle addition postulate, we had segment addition postulate, and now, I don't know if this is a postulate, it should be angle.
It is.
Yes, arc addition postulate, okay? And because I called it a theorem, which I shouldn't have, I should have called it a
On theorem sheets.
Yeah, your theorem sheet does say a theorem. Okay, this is number 4. Adding angles. Here's the congruent angles that you were asking for here. It should be arcs, congruent arcs. This is your note on your note sheet. All right. For 2 arcs to be congruent, they must have 2 things. First, they must be in the same circle or congruent circles. And they must have the same measure. So they must have the same length. You don't have to draw this part, but you can. Right. Here are 2 examples. I have a circle that's red right now. It's in the same circle, so this degree is the same as this degree. Since it's in the same circle, this length of this arc is going to equal the length of that arc. They are going to be congruent arcs. It doesn't work that way in this one. I have 2 different circles. They are not the same circle, and they're not congruent circles. So this 60-degree arc will not be the same length as that, 65-degree arc will not be the same length as the second 60-degree arc because one circle is bigger than the other. Just because it's got the same degrees doesn't mean it's the same length. Does that make sense? This little circle's not going to go as far as the big one. Okay? This one is going to because it's the same circle with the same radius. They're congruent. Those are not congruent. All right. You have a theorem. This is number 5, if you'll look at it in your theorems there. Arc-chord theorem. By the way, is this a central angle right here?
Mm-hmm.
I heard yes.
A what?
Is this a central angle?
Yeah.
What is a central?
No.
Why?
Because its vertices isn't the center.
Is vertices? This is not
wait.
a central angle. Okay.
Okay.
In the same circle or congruent circles, 1. Congruent arcs have congruent chords, and 2 congruent chords have congruent arcs. So, if these 2 line segments are congruent, then their chords, if those chords are congruent, then their segments are congruent. And if we flip it around, if these are congruent, then if the arcs are congruent, then the chords are congruent.
In the future, you.
All right, so if we have chords, then we have congruent arcs. And that's what we're saying right here. If the chord is congruent, then the arcs are congruent. Here's another one. The diameter perpendicular to a chord theorem. We're going to use this for a construction if we can today. If the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So, here we go. Let's get a picture up there. I have EB here. EB is the diameter. I'm saying if it's the diameter, and if it bisects this chord, then it cut it equally. All right, so if it's perpendicular, then if EB is the diameter and is perpendicular to CA, then what did we say was going to happen? What statement would I put here, you think?
Then it is then the 2 parts are equal.
Yes, and what would I name those parts, do you think? What are these parts here? What would I name them? What's equal to what? AG is equal to GC. Okay, let's see what. I also could have, I don't have their little arcs above it, I don't know why, but AB and BC. Okay, probably because I have a hard time doing that on my PowerPoint. There's ways to do it. I just have
to write the arcs on there.
this stuff you don't have to write down.
Well, like, do you necessarily have to write the arc things above it?
Oh, yeah, I would have to have, in your assignment, you're going to have to put the arc things, because I don't know if that's a segment or a line or what you're talking about. Yes.
AB could be, like.
Yeah, the AB could be this. That. We don't know. If you don't, tell me. Converse. Your converse is also true. So, basically, if one chord is perpendicular, bisector of another chord, then the first chord is the diameter. So this is what we're going to use today. If I give you a circle and I have no center in that circle, you don't know where it is, I'm going to ask you to find the diameter. I'm going to ask you to find the center. And so if we could just draw a chord and bisect it, I at least know that piece, that bisected one, is a diameter.
And then bisect that.
We could bisect that one, but they're going to suggest that you give another chord and find where it goes, and where it crosses will be the center. Okay? All right. So if this is true, if AG is congruent to GC and AC is the perpendicular bisector to EB, then this is the diameter. Okay? Stuff in there. Congruent chords. All right. In the same circle or in congruent circle, 2 chords are congruent, and this is the only way it happens. I don't know about the only way, but this is, if they are congruent, they're congruent if and only if they are equidistant from the center. Here's a circle. This is one of your theorems, by the way. We have these. These segments are congruent if and only if the distance from the center is the same. What number is that one, Heidi?
7.
Number 7. Okay, we just did number 7. Okay. We're going to do these. We're going to do these examples together. Oh, you can't see that very well. 9, 10, 11, 12. And then we were going to do 15 through 37 odd. We'll just see how that works, okay? All right, here's number 9. Number 9, right? That's the first one. I'm going to stay here with you guys. Number 9 says that we're supposed to name the arc made by the given angle. Angle 4. What's the arc? GD. I'm going to name it an arc. Okay? Okay.
What was that?
Mm-hmm. Number 10. The major arc for angle 1. BDA. And since it's a major arc, we need to do 3 of them. You could have put a C in the place of D if you would like. Okay? 9 and 10 are done. You with me so far?
Mm-hmm.
Okay. Let's now go to
12.
number, what's 12 now?
Central angle of the given arc.
All right, number 12. The central angle for USV.
US.
3.
Oh wait. Central.
USV goes clear to like that, correct? So what's the angle going with that one?
Angle 3.
Angle 3. Want to make sure everyone understands how we got that. You have to have 2 radii for that. Does that make sense, the rest of you?
Well, it's the opposite of what we did up at number 10. So I looked
Yes.
at what the relationship between BDA was and angle 1, and then just applied the same thing done at number
Let's go to number 15.
10. Perfect. Well, so.
All right, 15. 15 says, find the measure of the arc or central angle indicated. Assume the lines that appear to be a diameter are actually diameters. So does any of those look like a diameter to you?
No.
No. All right. So what is that question mark going to be? How do we measure central angles? Let's do this. How
Are they
big
the
is...
same
Oh,
as-
95.
Yes. This one was I was going to give you, yes, it's 95. That one's 120, and this is 95. So the question mark is 95. Very good. Oh, we're going to do odd again. All right, number 17.
Wait, so are they all just going to be like the same exact side thing?
Yes.
Oh, that was
Pretty nice, huh? Find the measure of the arc or central angle indicated. Assume the lines which appear to be diameters are actually diameters. So what's that question mark going to be?
60.
60 degrees. Done.
Mm.
19. Scoot it over a little. All right, again, the same thing. This time I'm looking for IDE. IDE. Now, be real careful. It's said to assume that things are diameters. This is a diameter right. This is a diameter right there.
Mhm.
So how big is this one?
180.
180. What about this is also
Is that
a diameter? And that's also how much?
180?
That's 180. So if that's 180, we know this part's 55.
Oh,
So how long is that one?
180 minus 55.
So it's 180 minus 55.
125.
125. Please confirm that.
Yeah.
Verify. Thank you. All right, 21 has the same instructions. This time we're finding an arc instead of an angle. We're finding LM. Are there any diameters in here?
No.
All right, how are we going to find that little piece?
We add everything else together.
Okay, so what?
We take 360 minus everything else.
So do you want to add all those things up for me? The 55, the 105, the 101, and the 39 for me?
300.
300, I heard. And so why did we subtract it from 360?
That's the total.
Because that's the total. So 360 minus 300,
60.
60 degrees. 23, this time we're going to solve for x. Assume that the lines which appear to be diameters are actually diameters. Are there any diameters here?
Yes.
Are there any vertical angles here?
Oh wait, what number?
Where are we?
23. We have some diameters and we have some vertical angles. Don't forget about
Yeah.
vertical angles.
65 and 65.
This 65 and 65
vertical.
is a vertical angle with that, correct?
Yes.
So then that 65 and 65 is the same as that x plus 130.
130.
So that 65 and 65 is 130?
Yes.
Okay. So 130 equals x plus 133.
How do you have a negative angle?
You don't have a negative angle, you have a negative x.
Oh.
Okay, very, very important to the difference.
Yeah.
-3, correct?
Yeah.
Yes. Very good question. Can't have a negative angle, but you can have negative x. Actually, when we get to do more stuff, the negative angle just means instead of going clockwise, you're going counterclockwise, or the other way around, whichever. All right, so now we're doing 25. What's the relationship here?
90
Isn't-
equals.
Okay. Wait, what are we supposed to be doing then?
Number 25.
So we noticed that they gave us extra information. This is the angle that goes with that arc. That central angle, and so that just means 90 equals -11 x plus 2. I got -8. Does anybody get that?
That's what I got.
Good. Again, we verified that it's okay to have a negative because it's not a negative angle, it's a negative x.
No, I wish we weren't allowed to have a negative.
I know,
All right,
we're gonna
27. Whoa, whoa, whoa. All right, so what are we going to do with this one? It said find the measure of the arc. We're trying to find IDE. IDE. We're trying.
Wait. Oh, okay, never mind.
So what are we going to do that? Careful.
Too many numbers.
Yes.
Primary measures.
Whoa. No kidding.
Couldn't we do the same thing we did on the other one, like the add them all up?
Uh-huh,
like
and
the
they equal how
police-
much? 360, right? So I might do this to make it so that I don't have to write a whole bunch. I might add up all the numbers. So the numbers like -1 and 1 and 96 and 50 and 55.
Oh wait, what is this?
The numbers out here, like the -1, the 1, the 96, the 50, and the 55. I might add those up and write those down. The -1 and 1 cancel each other out, so then 200 and something. 201, okay. So 201, and then add all the x's up. -101, -59, and +1.
Oh wait. Oh.
Negative 59? 159?
I got that, -159.
I got as well.
Oh.
Does that make sense to you?
And then it's equals or plus 201.
Uh-huh. Do you remember? And you're the one that had mentioned if we add them all up, they should equal how much?
And then equal 360.
Very good. So we're going to subtract the 201. And 201, excuse me, 360 minus 201.
159.
Woo! So x equals how much?
-1.
Very good. Don't forget the negative.
We're not done.
You are correct. Do not circle it. We're not done.
So it's wait, just one?
They didn't ask to find x. They asked to find the measure of the angle.
50 degrees.
So we're going to plug that -1 in, and -1 times -59.
It's +59 plus 1.
Yes.
Wait.
I know.
I'm like slightly behind.
It's okay. We'll let you catch up.
60?
Yes, that's the answer.
Oh my gosh.
All right. All right, I want to make sure, just a second, let's just make sure that 29, is it a similar deal for 29? Yes, but you're going to find the arc. Very similar to what we just did. Let me jump really quick to 31. 31. That one's going to be a fast thing. What is x going to be on 31?
16.
16. Do you understand why?
Because it's perpendicular.
Because it's, yeah, but not only that, they're both radii.
Yes.
Mm-hmm.
Okay? 33 now.
33?
Yes, this is a trick one. Don't let it trick you. It doesn't have to do with it anything about being perpendicular. That is a radius.
13. It's 59. 4.9 plus 8.1.
Isn't that 13?
Yes. Okay, so This right here is the same distance that this is over here, the 4.9 and the 8.1. So don't let it trick you.
What about 32?
34 has me lost.
34.
It would be 18, or 32 would be 18. wouldn't it?
How long is this whole thing right here?
Wait, 30?
30.
Oh.
Yeah, how much is just the radius?
Half of it.
Half of it, which is the same distance as that one.
Oh, so you do x minus 7.8
I would say
or 7.8 minus
7.8 plus x equals 35.4 divided by 2. However you want to say it. Does that make sense? What I just
Yes,
did?
it does make sense.
Did you want to do it differently?
I'll do the way I s-
Okay, you wanted to subtract. You could do it this way, Heidi. You could say 35.4 over 2 minus 7.8. Maybe that's what you were doing. Yeah, on 35. So this is the 6.8. This is the 8.4, and we're looking for the hypotenuse. So
It says to run it to the nearest 10.
6.8 squared plus 8.1 squared
Yeah,
equals
I would
x
just-
squared. We're going to solve that for the x. I'm not going to go through it.
Are they wanting us to take the square root of
It
it?
says, yes, they want you to because they're asking you to round. If they didn't want you to take the square root, they would have said leave it as in radical form. Okay. I'm not going to finish that one. We're going to go on to 37, which was our last one. And it was locate the center of the circle. This is a construction that I'm going to give you some tips on. I'm going to give you some tips on 37. 37 says to locate the center of the circle. You learned that if you have a chord, and if you bisect that chord, you'll have the diameter.
So make a chord.
So
and
make a chord
bisect
anywhere
them.
you want it and bisect it. Now, you won't be done once you find the diameter. The
Right.
question didn't say find the diameter. It said find the center, but that's the beginning. So bisect any chord. Pick one. I would pick one kind of near the edge, though. I personally would not pick a big one, but because it kind of, I think it would get in the way. So pick one on the edge of your circle.
Wait, how would you
Then bisect it. You've done that in the past. Do the perpendicular bisector. That will be the diameter.
Oh, you have to do 2 of them, don't you?
Yes, you have to do the full eyeball, not just the half eyeball. That's right. All right, so now you have a diameter. You have a choice now. The center is in the middle of that line, so you can bisect that one if you want it. Or you can come and get another chord, and do the perpendicular bisector of that chord. And where they meet will be the center. Okay? Your answer key on your assignments will do it the method I just did up here, where I found 2 chords in perpendicular bisector. That doesn't mean you're wrong. You'll just need to, when you're grading it, say, I know that this is right because Mrs. Stott said so.
Oh, I like
So,
that.
okay?
Yeah.
So, as long as when you do your test, and when I grade it, it'll look okay. So you could have done that way, or you could have bisected this one, done your little bisectors up here and your bisectors there, and get
Instead
your
of asking me to draw a perfect circle, I'm happy.
center.
My hand always moves when I'm trying to draw a circle with this thing. Do not
My
have
lead
the
and
most
stuff is
steady
always
hand.
like
All right.
So cool.
I did one each way so that way when I'm looking back I can remember.
That's kind of what I was trying to do. But, okay, so now that I drew that one, all I would do is come and just do it here.
All right, this is what we covered in this lesson.
Right?
We covered central angles, arcs. You know how to measure arcs. You had 3 theorems and a postulate with information about these arcs. Goodbye.